I'm going to do a really quick introduction because this session is going to be run by our Chief Architect, Alessandro Spadoni, and our Head of Engineering, Stephen Houston. It's a very similar format to what we've run in for the past few sessions. Alessandro will lead it. Stephen will be joining and contributing. And then at the end of the session, we'll have again another 15 minutes Q&A. So please be sure to drop your questions in the end. And we'll just kick off from there. Alessandro, I'll hand over to you.
Cool. Yeah, just a very quick introduction. Alessandro Spadoni, Chief Architect. I've been part of the B3i initiative since the very, very beginning, when it was just a round table, since the very first meeting. At the time, I was working for Zurich Insurance, and I was seconded into B3i until I became a permanent employee around a year ago. Stephen?
Yes. So I'm Stephen Houston. My background is in insurance and telecommunications. So I was with B3i way back at the start as well, where I was seconded via Liberty Mutual and have become a full-time employee with B3i and I now lead the engineering delivery department. Back to you, Ali.
Thanks, Stephen. Okay, cool. I'm going to talk about B3i Re, the Fluidity platform and the network. There's a lot of topics that we could talk about, and given the limited amount of time, we had to be a little bit selective. I'm going to try and keep this to around about 30 minutes, 35 minutes, and I'm going to give you some optional topics at the end that we can either dive into, or you can pitch in with some specific questions if you want us to cover something that you're particularly interested in. Okay, so first thing to say is, despite the fact that we're all here to celebrate the release of version 2 of our reinsurance solution, we've done so much more than reinsurance, and I want to share some of that with you now. So we, in our journey to delivering this reinsurance solution, we started with R3's Corda DLT platform, really good general purpose DLT platform, provides a consensus protocol, cryptographic signatures, immutable records, single source of truth, all the good stuff that we know and love about blockchain and DLT. We then elected to enter the Corda network, which is a cross-industry DLT network run by and governed by the Corda Network Foundation, and also operated to provide node identity certificate issuance, node discovery, and notarization. And I'll explain a little bit about the rationale for being part of that network later on. But then we started to build our own stuff on top of all this. So we established the B3i network, and the responsibilities there are for managing legal entity identity, membership and discovery within the network, network management, and to create an ecosystem of interoperable applications. And then we built something that we call the Fluidity platform. So this is a general purpose insurance platform, provides common insurance services and components, things like a common data model, and it's all to support heavy reuse, rapid time to market, and interoperability between applications. And then on the top, we built the B3i reinsurance application. So, you know, when you look at this stack, the B3i Re app, despite how broad it is and deep it is, it's really just the sort of top layer of what we've built. It's a dedicated application for reinsurance admin, but it only has reinsurance specific features. All of the common stuff, which is at least 80% of what we built, has been pushed into the lower levels of the platform. And much of the work that we've done in particular this year is much more than skin deep, and much more than what you'll see from the demonstration of the product itself. We've done a lot of heavy engineering in the Fluidity platform to build for a strategic future of B3i, which I'm going to take you through now. So I'm guessing that maybe some of you have heard about this, and maybe you've heard me talk about it, but worth a recap. So we have a strategy in B3i which is beyond reinsurance. We want to build a platform and a network and an ecosystem. The brand that we use when we talk about these concepts, the strategy is Fluidity. So I'm going to tell you very briefly about each one of those. So I mentioned earlier the Fluidity platform. Just to reiterate, it's a set of services and components that you can use to rapidly build new applications. And then we want to realize lots and lots of applications on top of that platform. The value proposition is really straightforward. By reusing the platform, you can build applications more quickly, and crucially, you can build them in an interoperable way. And I'll tell you more about that later on. R3 Corda is a great product, but you can't solve directly an insurance problem out of the box. And that's why something like the Fluidity platform is so important if you want to solve insurance problems. Then we get to the business network. So the B3i network, we've elected to be part of the Corda network. I'll explain that in more detail later. But I will say the rationale there is we're an adjacent industry, which means that we need to sell our services to other business networks, like, for example, shipping insurance to the shipping industry, maybe want to buy services from the banking industry. And pretty much insurance is connected to everything in some way or other. And therefore, given that interoperability is a kind of foundational core or a cornerstone of our strategy, having a model where interoperability is built in at the network level is something that was very compelling for us. So that's why we decided to be part of the Corda network. The B3i network is essentially a private permissioned business network inside of the Corda network, such that the services, the onboarding KYC that we offer mean that if you're an existing participant and somebody new joins, it's very likely they are who they say they are and therefore are safe to do business with. And you can imagine anybody directly or indirectly connected to the insurance industry being a member of our network. And then finally, if you have the platform, you have the network, that opens up the possibility for an ecosystem. And B3i, still a pretty small organization. We don't have the means or the appetite to solve every problem that exists in the insurance industry. We want to create the ecosystem to allow partners to come in and build solutions. And the spectrum that we see there is, at one end, existing members that maybe want to drive some efficiency in existing business or exploit a new opportunity they have. They don't necessarily want to build an app that they're going to monetize. They just want to solve a problem for themselves, right through to commercial organizations, software vendors, suppliers that identify a common problem in the industry and want to build a solution for that, and then distribute and monetize it across the industry, the network. We see threefold benefit here. One, it's the quickest way for the industry to solve problems and get value. It's the quickest way for B3i to scale the network and the ecosystem of applications, and it's an opportunity for product vendors to come in and unlock value. So that's Fluidity. I'm going to go dive a little bit more into the platform, and then I'm going to loop back to talk about B3i Re specifically. So I mentioned earlier that much of what we've built is beyond the B3i Re application, and this picture here sort of demonstrates that. These are some of the components, the main components in our platform that we have built and immediately integrated into the B3i Re application. So on the bottom left there, you see a bunch of network services. So things like the Party Network Membership Manager, which is what we as a business network operator use to record your membership and manage your membership in the network and make you discoverable to other users of the network. We have a service called Node as a Service, which is to help you onboard more quickly so that you don't have to build your own on-prem solution, on-prem infrastructure if you don't want to or you haven't got the means. And we've got a whole bunch of other network services and integration with identity provider. We have some specific components as well, which provide more rich insurance industry specific capabilities like clause management, technical accounting, risk portfolio management, those kind of things. And then the thing at the bottom right here, this we call the risk transfer language. This is what we feel is very, very important strategically for us, for the industry. It's a common insurance industry domain model, an implementation of a domain model. And I'm going to tell you a little bit about that now. So when you think about the way that we structure insurance contracts in a prose-based way, of course, we know the limitations there. It makes for a contract uncertainty, and also it makes it very, very hard to computationally process an insurance contract and have absolute certainty of how risk is structured in the terms and conditions. So our approach has been from the very beginning to move towards a structured model that allows you to structure risk for any kind of insurance contract. We have certainly focused for the time being on reinsurance and certainly in the short term on Nat Cat XL, but we're already starting to cover more contract types, which will come a little bit later next year. Our model allows you to structure risk in a very, very flexible way, but in an unambiguous way. And we can think about this, in the context of DLT and blockchains. People talk all the time about smart contracts. This is where much of the smarts is, because what it means, if you structure your contract using a language like the RTL, a data model and structure like the RTL, it means that you can then reason about business events that occur and impact that contract. So like a loss event, a claim that happens, we can determine which part of the contract is impacted and what the liability is. And this is very important for us. And it's also important from the interoperability standpoint. And I'll tell you a little bit more about that later on. What you see here in this picture, by the way, guys, is just a very small example or a small excerpt from the model. It's actually pretty broad and deep. So we've got, I won't go into all of this detail, but we've got layers of the RTL, which are about managing the business network and membership. We've got common base concepts like how we describe people and companies and capture documents and locations. We've got a general purpose contract model, and this is something that's nothing to do with insurance. It's a general purpose model that allows you to define a contract and the parties and the roles they have within the contract, define unstructured clauses, and define things like fees about the contract. And we intend at B3i to even use this model, for example, for managing our membership contracts on Ledger in the future. So that's how flexible it is. Then we move into the insurance specific layers. So we've got, we extend contract into insurance contract and start to bring in concepts like coverages, risks, reinstatements, reinsurance contracts, treaties, portfolios, how they link together, and a basic process orchestration process as well. So it's a very wide and deep model. I would say of course, we haven't covered every single permutation of every type of insurance. That would be, it's going to take a long time before we get there. However, what we've done is we've factored a lot of common stuff into the abstract layers of the model, and we built the model in a way that it's extensible. So hopefully when we start to introduce more use cases and different lines of business, we can do it through extension and limit the amount of change that we have to suffer in the model. Of course, we certainly won't have got everything right, but we've spent a lot of time and effort to minimize the possibility of that. So that's the risk transfer language. And I want to just talk a little bit now about how, when you use a language like the risk transfer language, the whole smart contract language and DLT, how you can deliver a single source of truth that's immutable. And when we just think about this in the context of B3i Re and the Nat Cat reinsurance contracts that are being written there and the kind of benefits that this approach can bring. So the way this works, and this is a little bit of a, let's say, a logical explanation of how Corda works and how we're using it. So let's say we've got a fictitious scenario here. We've got an insurer and a reinsurer. And there is let's say there's a reinsurance contract already in place. It's been signed and we're doing some kind of an endorsement, some sort of a change to the reinsurance contract. So what we want to do is move the reinsurance contract from version 1 to version 2. What are the mechanisms that allow us to do that in a reliable way to preserve the single source of truth and the immutability in the signatures? Well, this is kind of how it works. So this contract that's been written on Ledger, the first thing to say is it's written using the risk transfer language, which concretely, for those that are technical on the call, it's a Kotlin library of the classes that reflect the model that I showed earlier, plus states and governing contracts and commands. So those contracts are written as states, and I want to change them. So the insurer says, well, I'm going to make this change. Maybe I've increased the amount of coverage or something. And so the insurer wants to essentially propose a transaction to make this evolution of the contract. And as part of that, he will define which are the participants that are required and what signatures are required. Now, in this case, nothing will change. We just have two parties on this one, the insurer and the reinsurer. So that's already predefined. And then we'll select as part of that transaction the governing contract, as we call it in the B3i parlance, which it's essentially the part of the smart contract in the sort of logical sense. It's the code that that is triggered that checks whether the evolution of the reinsurance contract from version 1 to version 2 is allowed. So it can check, it will do all the validations, and it might check, for example, the certain mandatory data is there, whether certain structures are in place, check any kind of conditions that you can possibly imagine. Some of these checks are written directly into the governing contracts. Some of them are delegated deeper into the RTL for things that are absolutely common. So, I'll give you a silly example. One check that we might do is, because it's a contract, we might say, are there at least 2 parties involved in the contract? No, there aren't. Well, then this transaction is not valid, and we can't evolve the state in this way. But let's say, for example, in this case, the governing contract executes without exception, and all the validation passes. At that point, we can then sign this transaction, and everything is signed together. So all the contents and the code that was used to actually execute this transaction and perform the validation. That essentially, that proposal, if we want to call it that, is sent to the reinsurer, and his job at this point, what Corda will do, is to execute exactly the same logic, to perform the same governing contract checks, so that on his side he can be confident that the evolution of the contract is also valid. If he is, then he can put his contract on there, and at that point the transaction is deemed successful and it's committed to both vaults. And at this point, you've got consensus is reached, and you have a guaranteed single source of truth, even though on both sides you have essentially a physical copy of the reinsurance contract. Logically, it's a single source of truth. I think, Steve, you might want to add a little bit more on the technical side of Corda. I know this was a bit of an abstraction and a sort of logical view of how Corda works. Is there anything you'd like to add?
No, I think you've done a really good job there, Alessandro, covering the main points. From a Corda standpoint, what we've done is we've made sure that as much of the logic as possible is down in the governing contracts, which means our governing contracts really do enforce what the invariants are of these insurance contracts, and they're a little more complicated as a result than most standard complex contracts that you'll see in the example code and so on. With that as well, we've done a bunch of stuff to ensure that they can be upgraded, that they can migrate between versions and so on. So it's quite a significant amount of work has went on top of the fundamentals that Corda provides to us. So back to you, Ali.
Cool, thanks, Stephen. Okay, so this is how we achieve the single source of truth. This is this is the essence of the whole thing, right? What I see is what you see. The platform guarantees that, and we're using a standardized language in the form of the RTL, so we can have absolute contract certainty. And let's talk about some of the advantages here. So when we look at some of the problems that you have, let's say in a pre-DLT world, where in the best case we've got heterogeneous IT systems at each counterparty. The insurer's got something, the broker's got something, the reinsurer's got something, and we might look to a standard like a CORD and implement messaging between these heterogeneous systems in a bid to keep everything in sync and really chase the same goal that DLT is chasing, which is to ensure and guarantee a single source of truth. Even in that case, we still have lots and lots of unknowns. So, I could send a counterparty a message, but how do I know that he's correctly processed it? I mean, ultimately it's a message. You need to take that message, interpret it, probably convert it into his own proprietary form. I have no idea that he's done it correctly. He might believe he's done it correctly and even acknowledge back to me, but I have no guarantee. Okay, so with that, if I have no guarantee, then I fall back to wasteful processes like reconciliations. How can I be sure that my counterparty hasn't changed his version of the contract without telling me, maybe by mistake, right? I have no way of knowing. I don't know that he will definitely send me a message if he changes it. Anything could go wrong in the process, that's without talking about maybe somebody that's changing the contract for nefarious reasons. How can I be sure that the invoice is correct when he sends it to me? Why are his numbers different than mine? Well, we're probably not looking at quite the same thing. Well, the DLT platform keep these physical copies in sync through the messaging and consensus. It does that for us. We don't have to think about traditional messaging. All of the nodes are executing the same smart contract logic. We get the single source of truth. Therefore, we eliminate things like uncertainty about the numbers and what's in the contract, and everything's immutable. It's digital signatures ensure that tampering and inconsistency is very easy to detect. And then beyond that, what if there was a dispute? How can I prove which version of the contract was agreed? Well, if it's been signed digitally by all the counterparties, and that's indisputable proof that it's been seen and somebody has triggered a digital signature. IT costs, I'm going to come back to contract uncertainty. One of the good things about, let's say, DLT and distributed approach is it's all about mutual processes. That's where you get the most value. And if we can look at the partially non-differentiating problems together, build one solution and deploy it and leverage it across the network, it means that we don't have things like data translation, messaging. We can have one mutual process and one shared application. So once you scale out, you start to get economies of scale and really potentially really big benefits. The contract uncertainty one, the reason why this is a yes and a no, like I mentioned before, our risk transfer language is all about creating a structured, unambiguous representation of how risk is covered in the contract and the terms and conditions. However, we recognize that there are lots and lots of weird and wonderful prose-based clauses out there, and it will take time before all of those clauses, if we ever fully get there, are structured in a way that can be computationally processed. So this means that we can provide a certain level of contract certainty, but what we can definitely do is, for example, when a claim comes in, we can look at the contract and process it computationally and say, well, it definitely, based upon the type of peril, the location, the class of business, et cetera, I can, and the date that it happened, I can point at this coverage in the contract, which is where it's likely to be impacted. But hang on, guys, there's a clause on there, or there's 10 clauses, so we can just mark that and then give it to a human to eyeball it. But already before they get to the point of having to eyeball the whole contract, we've already led them to a place where potentially the contract has been impacted. So directionally, we want to move more and more towards contract certainty through structuring, but it will take a little time. Okay, and then finally on this risk transfer language, this is a really, really important thing for us with our strategy. So when we talk about DLT, it's always, most people talk about it in a bit of a silo. They talk about reinsurance, for example, and we talk about having an indisputable record and single source of truth for a reinsurance contract between an insurer, a broker, and a reinsurer, and that that all makes perfect sense and eliminates all that waste that we talked about. But we view the single source of truth way beyond a single application. We view it potentially across a whole ecosystem and network. And if you look at this example, just to illustrate the point, so let me just see if I can draw on this. So we have a kind of fictitious network here. We've got an insurer, and let's say we've got a broker, right? And the insurer is placing business with the broker, and broker's working with the reinsurers downstream, right? These guys are using our reinsurance application, our B3i Re app, and they're very happy, and they're writing these contracts as separate physical copies, but logically one single source of truth. Corda and the Fluidity platform is providing the single source of truth, the lack of ambiguity and all of that good stuff. But imagine, and all of these contracts are written in the risk transfer language. The states that are written on Ledger connected to a graph of objects which are pulled from that Kotlin class library that I talked about. But imagine then the insurer over here, he wants to start selling property insurance in, let's say, in Switzerland, and he builds himself an application for doing that, and he builds it on Fluidity and deploys it onto his node on the B3i network. And now he starts writing primary policies to people like us, and he's writing those in the risk transfer language again. But then he wants to aggregate that risk or seed it into some reinsurance. Now, with our approach, with the standard language, what it means is all of these contracts that are written upstream can now be connected to the reinsurance contract. The reinsurance application can consume those primary policies and reason about the contents of those policies and understand how they impact the reinsurance. And we can imagine this also from, in terms of events that happen that cascade through this chain. You can only do this in a reliable way, in a DLT native way, if you're using a standard language. Because if you haven't got a standard language between this application and this one, then at this barrier here, there has to be some kind of messaging, some APIs called, some sort of translation. And by definition, if you do that, you no longer have a single source of truth. No matter how much engineering and testing you put into that translation layer, you cannot rely on it entirely. And therefore, you lose the benefit of a single source of truth if you're sharing facts, you're sharing data, in this case, sharing contracts between applications. What our approach with the RTL does means there's no traditional integration, there's no data translation, it's a DLT native, and it allows for the cascading effect of all of these connected contracts. So an example would be, a silly example, let's say I have a policy up here, and I have one of these policies, and as part of that, I've provided an inventory of the things that I own that are more than 2,000 euros. And then later on, I decide I buy a brand new mountain bike for 6,000 euros, and I want to add it to the list. The impact of that increase in cover can be connected and felt all the way through the risk distribution chain. And this can, with this, all this could be retroceded. It may even end up on the ILS market. Now, I know me adding an expensive mountain bike is, in isolation is not material. But in aggregate, any of those impacts that happen across the chain can have a significant effect on the way that risk is distributed. So this is where we see the potential, the future potential, enormous benefit when you start to create this ecosystem. Okay, a little bit on the network architecture, and then we can get into questions. So I mentioned before that we're part of the Corda network. So for those of you who don't know about the Corda network, it was something that was baked into R3's vision for their product, and it was one of the things that really attracted us and excited us about their strategy. R3 have this vision of a network of business networks. I think you could probably describe it as. So the idea that lots and lots of separate business networks that do business internally, but also need to transact between themselves as well. And so with that, they set up something called the Corda network. We pushed R3 quite hard at the very beginning, and as did a lot of their customers, to say we love the vision. We think it's absolutely, really, it's a really directionally a great way to go, and it's perfectly aligned with our strategy. But we're a little nervous about a third party being in control of this thing. So that provoked R3 to create something called the Corda Network Foundation, which is a separate legal entity that's it's based in the Netherlands, and it's a corporate structure that's good for these kind of foundations. So the job of the foundation is to govern the membership of the network, the principles and overall direction of the network, and to also provide some operation services, so things like notary and discovery and certificate issuance. By being as part of this compatibility zone, as they call it, it means that we can do business in a very low friction way with other networks, and ultimately, as I said earlier, insurance doesn't exist as an island on its own. So we thought we'd go into the Corda network, but within that, we've created what we call the B3i Business Network, and this is governed and operated by B3i. Membership is governed by us, and you have to pass through our KYC and onboarding process, some of which we share with the Corda Network Foundation, because in order to be a member of the B3i Business Network, you also have to be a member of the Corda Network, and we sponsor that process of onboarding you into the whole thing. we provide member onboarding and discovery services and other network services like Node as a service to make it easy to participate. So, when you join, you're part of the network. You can start do business together, but because you're part of the overall Corda network, it means you can also do business with other business networks that are outside of B3i, which is ultimately where we need to be. What we've also layered into our model and that we're making available very soon is also the concept of subnetworks. So we've had requirements from our customers, maybe some of you that are on this call right now. They want more of a ring-fenced, protected area within the network that they can govern themselves. So perhaps if they're working with on some co-insurance or in partnership with some other participants of the industry and maybe some important customers they want to put a bit of a wall around all of that and have as a control point for membership, for discovery, and a distribution and control point for applications that are available in that network. So we can have more companies that are part of that subnetwork that may or may not want to do business outside of that subnet network with the wider B3i and also beyond. So with this, what it means is we can tackle some of the challenges and fears of being in a public network. We can provide mechanisms that give our customers the ability to have a bit more control themselves and let's say get some comfort and additional security by being part of their own subnet. And that's all I wanted to push on you guys. So I'll pause here and just say it's an opportunity for questions. I have a bunch of extra material to cover other things like security, data flow, DLT 101 if that was something that people want, or integration. So they're optional, or we can dive into any other topic that you'd like. I think over to you, Red.
Thank you. Yeah, thank you, Alessandro and Stephen. I think that was a really good view of the architecture and B3i Re's relation to that as well. And I'm sure we could have spent a lot more time on that. But this is over to you guys. Do you have questions for Alessandro and Stephen on this subject? Please drop them in the Q&A section feature function below. Questions already coming in, great. Keep them coming, and I'll keep putting these to Alessandro and Stephen. So Alessandro, first question, is RTL a published language / protocol that can be publicly commented on?
That's a really good question. So right now it's not. We retain the IP for it, and it's proprietary B3i. However, we are looking very, very seriously into into options around open sourcing that and making it more freely available. Honestly, the only reason why we haven't fully done that yet is purely down to capacity. So the overhead of governing such an open source model is something that we haven't had time to do until now. But it's a direction that we want to move into.
That's fair. Plenty of other priorities, I'm sure both of you all agree. So whilst we wait for some more questions to come in, I do have a question, something we didn't pick up on and you've put here on your list is integration. That's come up in the products team session. Did you want to give us a quick overview of some of the integration that has been going on?
Yeah, perhaps maybe Stephen, you might want to talk to this one actually, if that's okay.
Sure. So what we've been doing is some integration with existing incumbents in the market. Primarily, our big integration so far has been with FSRI from MSG, where we've got a working integration that allows our placements done in B3i Re to then be transferred over to FSRI, where they can follow the rest of the life cycle. We've also recently did our technical accounting module, and then we have feeds out of it that can then be consumed into other applications. I've been working closely with product called Rita from one of our partners that actually can help bridge the gap between the traditional systems and our technical accounting system that we have built ourselves. On top of that as well, we've got a strong API, RESTful API that allows for easy integration in. So if people want to build new applications that can consume our DLT native solution, they don't have to go the whole way and jump straight to being DLT native. They can actually go through our RESTful JSON API and get an easy to use and easy to consume interface. But on top of that as well, if you do want a deeper integration, we actually do have core app services available, and we also have our RTL, as Alessandro has talked about, and we have various components in the Fluidity suite that allows you actually to construct these core apps more easily and more efficiently, so that you can actually build your new core apps, integrate those in with your existing solutions through whichever means you deem necessary. So we've got a variety of different options for integration, and we welcome definitely more integrations in the future as well, and more partners building on top of those.
Absolute textbook, perfect answer. Thank you, Stephen. I think this one dovetails nicely with sort of integration. The question is, how will external events be captured in the long term for contract certainty purposes?
External events. Example, what would that be? Like a loss event, like a hurricane, for example? Is that what we're talking about?
I didn't know if it was talking about off ledger. I don't have those details, but I think it was off ledger. Perhaps Tom can clarify, such as a hurricane. There you go.
Such as a hurricane. Okay, so the intention is that we will work with first of all oracles that provide this kind of data in many cases, so they can provide a sort of immutable, reliable record that something's happened, what it was that happened, when it happened, where it happened. And we use that then as an immutable source of truth, and we can then start to we can take that fact, that event, and evaluate the contracts that are potentially impacted by that event. So that would be one source of data. It's not an integration that we've done yet, but also maybe another example might be if you're in a situation where your primary policies are not being mastered on ledger, you're just using reinsurance in the case of B3i Re, for instance. There'll be integration between your primary policy admin platform potentially that's capable of sending maybe a claim event into B3i Re for processing. So those kind of events. I'm not sure whether that answers the question, Tom. Or...
Hopefully Tom might be able to elaborate, but I suspect that answer. Yeah, there you go. Tom says yes, thank you.
Okay, cool.
We've had a question here. So can you talk a bit more about the upgradability of Corda, Fluidity, etc. of RTL components?
This is a really good question, and it's one that we've spent a lot of time thinking about. It's a fairly complex thing, right? So one of the challenges that we have is if we deploy a version of the software and we start doing business, and we start writing contracts, these contract states, and all of the stuff that hangs off them, it means that when we come to do an upgrade, so let's say, for example, we've got a contract written on Ledger and it's written with version 1 of the risk transfer language, and then some months later, because we've incorporated a new line of business or something, that we've extended the risk transfer language, it means that we've now got 2 versions of the risk transfer language, and how do we deal with those old states that were written with the previous one? Well, we've done a lot of work to look at migration patterns. So the idea is that when we deploy a new version of the risk transfer language, that we will pull the old states that were in the previous version out, and we'll convert them into the new version of the RTL, and sometimes we'll have to write some migration code as part of that, depending on the nature of the change. So if it's a complex change and it's not through extension, it's likely that we'll have to take something from the old version and figure out how to map it to the new one, and then we rewrite the state in the new version of the risk transfer language. This is, it's non-trivial, and it's actually one of the reasons why in the DLT world, it's extremely difficult / impossible to do continuous delivery and deployment of features and functions as you would do in, let's say, more traditional software. So that's one thing. The other thing to note as well is that we've employed an N-1 backward compatibility standard. What it means is whenever we release a version of Fluidity, we have to guarantee that this version is compatible with anything else that was written in the previous version. one thing another thing we're cognizant of though is we want to avoid dragging too much of that backward compatibility behind us, because we're learning from the likes of Microsoft who were really badly burnt with earlier versions of Windows, where they had to drag a lot of backward compatibility. It turned Windows into a really brittle, unreliable, unstable piece of bloatware in the end. Apologies to anybody from Microsoft. And that's something that we really have to avoid, which is why we need to balance backward compatibility with the ability to translate and convert the old facts written in the old version of the software to the new version. And especially when we get into concepts like life and health policies that need to be visible on ledger and accessible for 10, 20, 30, 40 years. It's extremely important thing for us. Stephen, maybe you might have something to supplement.
Yeah, the only thing I was going to add to that one is was the Corda topic. I don't think you've touched much on that one, Alessandro, but Corda out of the box has some support for upgradability, but not a lot. You do need to manage a lot of information yourself. So in our states and domain models, we actually handle a lot of the transformations between previous versions, and the ability then to actually have one version of the model talk to a different version of the model, have different flows talking to other flows, and so on, to be able to sort out that kind of situation that you could be in, where the network isn't fully upgraded at once and you actually need to manage all the interactions between it. But one of the other things I want to touch on as well is that we've been working quite closely with R3 to make sure that the new requirements such as Corda isolation make it into the product, and those kind of features would allow for better integration or better ability to run multiple versions of Corda at the same time, and therefore promote the whole upgradability story. But certainly, I just want to echo and underline the point that unlike in a traditional web application or other piece of software, upgrades in the DLT environment are certainly non-trivial. And when you've got any kind of reasonably complicated domain model or reasonably complicated set of process flows, there's quite a lot of work that you and considerations that you need to bear in mind. Thank you, Red. I think Alessandro might have dropped.
Yeah, we might have lost Alessandro for a second. He's having some issues with his Wi-Fi, but that's okay. We'll get him back. He's come back already. I was just going to say that, yeah, thank you for answering that question, both of you. Really, it's obviously something that's really important to any technology company, but it's clearly top of mind for you guys. It's something you're considering. So it's great to hear that is on the radar. Anyway, we have another question from Dorian again. Is there similarity between structure of RTL and Accord? So Alessandro, you're probably most familiar.
Not much.
Maybe.
No. There's not much similarity at all. We've employed Accord, or will employ Accord at the edges of our application and Fluidity for integration with those parties that want to consume Accord messaging, but internally, we deliberately have not chosen Accord for IP reasons. That's it, frankly. Yeah.
Great, thank you. That's all the questions we have in the Q&A section at the moment. If any more come in, we'll get to them. We obviously have a little bit more time. So, Alessandro, you had some other points you did want to cover. You've got on here data flow. Is that one that you'd be interested in potentially touching on?
Yeah, let me share my screen again if I can.
And in the meantime, if there are any more questions, this is a great opportunity to ask them to Alessandro and Stephen. We'll obviously follow up with, we usually follow up with Q&A responses to these as well, so as we can put them on the website. And as always with all this stuff, we'll make sure that the slide decks and the recording is available after the session. But sorry, Alessandro, over to you.
No problem. Can you see my screen?
Yes.
So let me just go to, yeah, a little bit on data flow. And I think it's probably, most people will probably realize this, but it's important to describe what kind of data is flowing across the network. We've had a lot of questions around the level of privacy and people coming with preconceptions based upon public blockchains, and but we're in a very different world here, right? So when two members, as in this example here, member A and member B, the blue box and the white box, when they're doing business, the only parties that get access, that can access the reinsurance contract that's being passed backwards and forwards, and any messages that are passing backwards and forwards, are only those counterparties. There's no broadcast across the network. It's a point-to-point communication. So it's not shared with anybody. In fact, nobody else on the network should be aware that anything specific is happening. The only other pieces of data that are flowing across the network are when a member wants to do business with another member, then they have to discover that member, which means requesting some information from our business, from the network membership manager, to discover those parties. And of course, the information that's shared as part of that is anyway publicly available information. So, for example, you can query our network manager for all members of the B3i network whose name begins with S that are located in Switzerland that provide reinsurance services. So, and that's publicly available. So we're not disclosing any information that isn't available. And then, of course, as part of resolving then the node on which that legal entity is residing, so that you can actually start doing quarter transactions with them and doing business, you also need to look up the host name of their node, and that's provided by the Corda Network Foundation and the network map there. The final piece is the notarization of the transaction. So this is where when a transaction is signed, the notary is also involved to attest that the transaction has happened. And I think, Stephen, maybe you want to talk about the difference between a non-validating and a validating notary, and explain what information is actually transferred here.
Sure. So due to our privacy requirements, we use a non-validating notary. So just to be clear, what a non-validating notary means is it's one that records the transaction that's happened. So it records the consumption of the previous state and the production of the new state, but it doesn't actually see any of the contents of the transaction itself. So none of the information is sent to the notary, so it doesn't run any of the contract checks. It just assumes that because all the parties agree, it's able to actually then sign that transaction. In places where members trust each other and trust the contracts and so on that they're running, this makes a lot of sense. So when you're talking about our companies interacting with each other, this makes sense. But if you were to move into a more untrusted environment, then you do want a third party just to run through the contract and validate that nobody is trying to game the system. So if you had a case perhaps where you could have two potentially bad actors on a transaction, you may always want to have a third party check the information, check the data, and actually validate that it is correct. That's called a validating notary. And what it gets is the entire contents of the transaction along with the governing contract itself, and then executes the contract code against the transaction contents and make sure that it's all legitimate and that nobody's trying to game the system. But as I said, in our use case, we don't need this level of protection. Indeed, we actually don't want it from our privacy standpoint. So we've elected to use the non-validating notary. And actually, at present, that's the most popular type of notary on the Corda network.
Thanks, Stephen. Probably one other thing to say about this then is to imagine a fictitious scenario. So let's say that we wanted to move towards active regulation on the network. So this is something that we talk about as a sort of much longer term aspirational goal for the B3i network. But we can imagine a world where regulators, instead of defining the rules and demanding everybody follow those rules, and also demand that they're audited to check that they're following those rules, and potentially the regulator could be part of the network and maybe to be part of the consensus protocol for maybe transactions that happen within their jurisdiction. So you can imagine here, just to add this here, we've got one of the regulators, regulator number one, because this transaction that's happening between member A and member B falls within their jurisdiction, it's mandatory for this regulator to be involved. And maybe in this case, the example Stephen gave before, where you want this trusted third party to check things, this is an opportunity for the regulator to look at the contents of the transaction that's happening and execute some rules that might restrict that transaction from happening. So let's say the regulator would be the only party that would have visibility of how risk was distributed within their jurisdiction, and maybe look for things like risk spiraling and or maybe carriers exceeding some limits or reserving limits or anything that you can possibly imagine. And this guy could be part of the consensus as part of that. And so some of the data in this case would flow into the regulator, and they would also have to approve the transaction. Or even a different mechanism, if they weren't part of the consensus, the regulator here in this case could be just an observer of the transaction that's happening between member A and member B, such that when so they could do some retrospective checking and auditing of what's happened within their jurisdiction, and all these things are possible. But the point making here is this is entirely up to the industry, up to the requirements that we have. The good thing about Corda is we have this level of flexibility to define any fact on ledger. We can define who the participants are. We've added some capabilities to define observation of that, and we can control entirely the sovereignty and ownership and sharing of data in a reliable and private way.
Thanks, Alessandro.
Yeah, I think we've got 3 minutes left, so
yeah, I'm gonna have to wrap it. No, I'm really glad we got to touch on this subject. Regulation, the ownership of data. It does come up really, really often. We do have one final question, which I will allow. So regarding the subnetwork, did you say that this could be self-governed? Would it allow restrictions to only its members? You talked about that earlier.
Yeah, so it definitely, we can allow it to be self-governed, and that's why in the picture I showed in the subnetwork, actually one of the members of that subnetwork being the kind of sub-business network operator. So the responsibility of that party would be to determine who was part of the network and manage their membership. We have plans to allow those subnetwork operators to make decisions about how public or private the network is. So for example, it could be that in some cases there is a subnetwork that that a BNO wants to advertise to the rest of B3i, and maybe it needs to be discoverable, and they want to attract participants into that network. Or in some cases, they might want to make that the existence of that network entirely private, and therefore the management and the membership would be more from a pull perspective, where the business network operator would invite other B3i members to come and join, and potentially everything in between. So yeah, the one restriction I would say though is, given that this interoperability goal that we have, and really with the best interests of the insurance industry at heart, we want to maximize interoperability, and that means different members of the B3i network doing business together, regardless of what other business networks they might be part of, or sub-networks they might be part of, and those members also doing business with other networks in the Corda network that are outside of B3i. Because without that, you really miss the chance for having a fully connected network and leverage the full benefits of DLT. So we're trying to provide just enough privacy and restriction to be compelling. I hope that answers the question.
I think more than answers, I assume. That's where we're going to leave it for today. Thank you everybody for sticking with us and joining us in the first place. Really appreciate you spending the time. For more information, we have the website b3i.tech. Visit there, or if you want to get in touch with any of the team or ourselves, please email info@b3i.tech or sales@b3i.tech on screen for you now. So all that leaves me to say is thank you for joining, guys.
Yeah, thanks for joining.
Thank you very much.
Thanks.
Bye-bye. Bye.